Good afternoon, everyone. Can you hear me? Hello?
Yes, we can hear you.
Okay, good, good. Okay, so first of all, welcome to 11 cam 1151. I know this is very different way we are doing because of COVID-19. So the safety should be our first priority. That's why I'm trying to minimize the lab time. So if we do this way, before coming to the lab, if you know how and what we will be doing, it is going to save your time. So I don't know whether this time is good for everyone, but I will probably ask the class again tomorrow. I can pick a different time, but it is very important that before you come to the class, you know what you will be doing and how you will be doing. So I'm going to take a few minutes. I'm going to share my screen, and if you have any question, I think there is a button. You can raise your hand or you can turn on your speaker. So I'm going to share my screen. So first I'm going to go over some of the important information you have on the syllabus. I hope you read the syllabus. If not, please do as soon as possible, because there are so much information you need to know before you come to the lab. Is there anyone who doesn't have lab manual? Everybody got your lab manual? Okay, you can send me text messages here, or you can turn on your phone and you can stop me anytime. So I'm going to go, first is the syllabus, and I'm assuming that most of you have completed the safety quiz. Am I right? Is there anyone who haven't yet completed? So let me show you. I'll go over the Canvas module. But before that, you should know that you must read the syllabus. And tomorrow, you should bring mask, goggles, long pant, lab coat, and shoes. These are required. Without these, you won't be allowed to do the lab. Now, this lab is not difficult, but you have to comply with all the rules and regulations. If you do complete all the labs and the pre-lab awards, very easy to get an A. But if you miss something, if you have an excuse, I'll try to help you. So make sure you inform me. Also, you need to complete the safety agreement. Have you done? And I'm going to show you how we're going to do it today. So I'm going to switch to the Canvas. So you see, the first one is the syllabus. It's very straightforward. We simplified the Canvas, so you don't have to worry about or spend time to look for the assignments. You need to go through the PowerPoint presentation, and this is the safety in general. Then you can watch the video, and this is the quiz I mentioned. You have to complete and get 80% or more. I saw most of you have completed, but I'm going to remind again who haven't yet completed. Also, you need to complete this form before you come to the class tomorrow. So I'm going to check again tonight, and I'll send a reminder if some of you missed it. Very straightforward. Then you're going to go over the PowerPoint presentation. Tomorrow I'm going to give you a demo. How do you pipette? But again, preparation is very important to save time. Since we will be wearing mask or face shield, it is not convenient to do a 3-hour lab. And that's why I'm trying to help you. So if you are fully prepared, you can finish the lab in 1 hour or maybe maximum 2 hours. You need to know how do you use the digital balance. Okay? So these two, you need to watch the videos before you come to the lab. Then I'm going to go over how do you fill out these two worksheets. Now these you are going to do after the lab, but these are due tomorrow. So I'm going to take a few minutes to go over the main objectives of tomorrow's lab. Again, some of you are not here, so I will take again few minutes tomorrow during the lab at the beginning to go over the safety requirements. But today I'm going to show you how do you complete these two. Some more important things about this lab. So this is an ADI lab. What does it mean? It means it is based on argumentation. You'll be giving some problems, and then you have to have some discussion. But before you are given a problem, you will be doing some experiment to gain some knowledge about some basic concept. Okay? So for example, tomorrow you'll be given some glasswares. And from the glasswares, you should be able to tell which one is the most precise, which one is the most accurate by doing some measurement. So before that, you have to know how do you use the glasswares. So that's the basic concept. Then, once you know there is a real world problem given, for example, if I give you two blocks, objects, how do you tell these two are made out of same material? Okay. So before that, I have to do some experiment to gain some knowledge about properties of matter. When you talk about properties of matter, the properties can be intensive or extensive. I'm talking about physical properties. Okay. So then you're going to write a proposal. Then based on your proposal, you're going to collect some data. Then you're going to present using a whiteboard presentation. Now, because again, due to COVID, you are not going to do all these for every experiment. We'll be using the entire ADI steps only for 2 experiments. So for example, the first experiment, we minimize. You are not going to go do this part. You're going to use 3 glassware to tell which one is the best or most precise and most accurate. So you have to know how to use the glassware. So for first experiment, you are going to write argumentation. The second experiment, after the presentation, you will write a draft report. Then it will be peer reviewed by 2 of your classmates. So you'll be graded that one. Then based on the inputs from your classmates, you're going to revise your report and submit the final report. Okay. Now I know there are too much information, so I'll go over again and again. So every lab, you will have some online work and some face-to-face. If we meet before the class, if you have any questions, I'll be happy to answer for your online works. You will be writing proposals, peer reviews, all are going to be online. In the lab, you will be following the safety protocols, collecting the data, and then if you bring your computer, we're going to give you a computer. Every station will have a computer. Then you go to enter the data. So we are not going to collect any paper from you. You will be submitting all the work online. Okay. So the first week, before you come to the class, you need to do all of these. Tomorrow in the lab, we're going to take few minutes to show the safety equipments. Then you will be doing the measurements. I'm going to show you right now what you will be doing and how. Keep in mind, you will be working individually. And then you will complete all the calculations. So these are the sitting arrangements. I assume that you got my email and you know your seat number. You will have assigned seat. First you will come to the orientation room. We have to maintain the social distancing. And once you are done here, you'll go to the next room, which is the actual lab. So these are also assigned. The lab workstations are assigned. Before you go there, you need to clean your seats. So we are going to provide you wipes. You clean there and then you go back. You take all of your belongings from this room to this. We're going to have cubbies here. You're going to keep your backpacks, all belongings in the cubbies. But you must be fully attired. You need to have lab coats, goggles, face mask, all the time. Also, you'll be using gloves. We're going to provide you gloves all the time. So once you are in the lab, then based on your seat number, again, from 1 to 6, and I'm going to remind you again tomorrow. You must know your seat number. 1 to 6 and 19 to 24 will go to the right. That means this side. So you will come from the orientation room and then you will work at your workstation. So for example, one student will be working here, another student will be working here, another here, and so on. Okay. This is very important. You have to follow the protocol. Now I'm going to take a few minutes what we'll be doing and how we'll be doing and why you'll be doing. Very, very important. Now let me stop here for a few seconds and let me ask you a question. Do you know significant figure rules? You can turn on your phone and hello? Anyone?
Yes.
Have you learned?
Yes.
Okay. Is there anyone who haven't yet learned? I don't mind spending few minutes because that is very important. You want to get a good grade? You want to do the calculation correctly. Do you want me to go over the significant figure rules?
Yes, could you go over it?
Okay. Okay, I'll be happy to go over. Okay. So, do you know what are the goals for this lab? You'll be given 3 glasswares. You could be, actually we are doing with 3, but in the past, by the way, I forgot to mention, I have been teaching this class. My name is Subodh Dada. You can say Dr. D or Dada. I forgot to introduce myself. I have been teaching this lab and other 3-4 classes for last 13 years. And I don't want to see anybody in my class get below C. So I try my best to help everyone. If you work hard, if you try your best, you'll be very happy at the end. So we simplified this one. Instead of 4, we are going to give you 3. Now keep in mind, this is just to keep the water. You'll be using a beaker, graduated cylinder, and a pipette. And of course, you have to use a thermometer to know the temperature of the water. So when you first go to the lab, you'll see these are already there at your workstation. Okay. You only thing you have to do, you just take the beaker and grab some water. Now when I say grab some water, and you will see around the lab, there are sinks. And each sink has 3 things. 2 faucets and 1 sprayer for eye wash. And I will show you tomorrow. So 2 faucets, one of them is white. That means that will give you distilled water, pure water. You know that water, that regular water is not pure because it has minerals. So you don't want to take the water with minerals because we will be using pure distilled water. So you grab some water. Then you take the thermometer and you stick in there for 2 minutes. You record the temperature. And I'm going to show you where you're going to record the temperature. Then you're going to take this beaker, 50 milliliter beaker. So first you're going to take the 50 milliliter beaker. Let me show you here. So you take this beaker and you put in there, in the balance. Now balance has 3 doors. 1 door, 2 door, 3. You can use any of them to put your beaker on the pan. So the beaker has to be empty beaker. If this is not 0, you just press the button here. T means tear, to make it 0. But make sure that all are closed. This is closed, this is closed, this is closed. So then you open one. If I'm right-handed, I'm going to open this door and I'm going to place the beaker here. Empty beaker. Then I'm going to see the mass of the beaker. Okay. You need to record the mass of the beaker. Once you know the mass of the beaker, So then you're going to take some water from this one and you pour in there. How much water are you going to take? You are going to take any amount greater than 10 milliliter. So then you have to know how do you read it. Now keep in mind the beaker is the measuring device here for the first one. Then you record the mass of the beaker plus water. And you're going to repeat these measurements 3-4 times. So once I know the mass of the beaker plus water, then I can subtract the mass of the beaker. So I'll get the mass of that is going to give you the mass of the water. Okay, you're going to repeat the measurement 3-4 times. Then you complete the first column. Now the first column, if you have the lab manual, that is going to be, I would suggest that first you write everything on your lab manual. Then you log into your computer. That is going to be page number 9. Okay, and I have a scanned copy. I'm going to show you in a few minutes. So then you are done with the beaker. Once I'm done with the beaker, then I'll go to the next one. So I'm done with the beaker. Now, for the next one, this is going to be my measuring device. And what is this? Graduated cylinder. So you have to know how do you read a measured value using a graduated cylinder. Okay. So first I have to look at the smallest division in the graduated cylinder. For example, I'm going to show you here. Here, can anyone tell what is the reading showing in this graduated cylinder? You can use the chat window and enter a value. It's all about learning, so don't worry if you get wrong. Sometimes you do mistake, you learn more. Anyone? $20.5, 21. Okay. What do you think? So how do you know how many decimal places should I use for this graduated cylinder? So this brings the question, the significant figure. What is significant figure? Let me see. Somehow. And where this number come from? So significant figure. Very easy to memorize the rules and apply. But if you never learn first time, it is extremely difficult to understand the significance of the significant figure. And with time, hopefully you'll learn. So there are two numbers in this world. One is called exact number. Another is called measured number. Okay. So for example, if I have 20 cents, How many significant figures are there? Unlimited, because it's an exact number. So when I use this number in any calculation, it is not going to limit the significant figure. Now again, I will repeat tomorrow with some more example. But if I have 20 milliliter water, how many significant figures are there? Anyone? 2? No. 1. The 0 is not significant. Okay? So how do I know how many significant figure it should have and how do I write it? That is going to be your goal. Very, very important for 1150. And you're going to see some questions on the final, both for 1150 and 1151. So in this is measurement, you see the 20. If I cannot write 20, because I can see it is more than 20. And you see the smallest division, you have 1, 2, 3, 4, 5. So 10 to 5. Smallest division is 1. It's 1. The rule of thumb is that always you take 1/10 of the smallest division. That means if I use this graduated cylinder, I have to use 1 decimal place for reporting a number, measured number. So this is going to be 21.5. It could be 21.4 or anything else. So this is where uncertainty comes. The uncertainty. I cannot take more than 1 digit, which is uncertain. So the number is going to be 21.5. Someone can say 4. Someone can see all are correct in terms of significant figure. That means if I write 21.5, how many significant figures are there? 3. 3 significant figures. Sorry about the phone. Okay, but if I write 20 milliliter, that would have only 1 significant figure. This one has 3 significant figures. Okay, so why you are using significant figures? So with time you're going to learn. Okay, but first you're going to apply in the lab. So when you use graduated cylinder, if I see the smallest division is 1, I'm going to use 1 decimal place. Okay, so the procedure says you take more than 10. I can take 11.5 or 10.5, but you don't have any control. You take some water and then you do the measurement. You don't want to take the same value again and again. That is very important. And when I go to that page, page number 9, I'm going to show you how you're going to write. Okay. So you need to know the rules for significant figure. One rule is how do you do the measurement? How do you write a measured number or report a measured number? So the rule is 1/10 of the smallest division. The measured number will come from, or the significant figure will come from the device, not from the measurer. Very, very important. You cannot write on your own. Okay? You have to write that makes sense. When I use a calculator, your calculator doesn't know whether you are using an exact number or measured number. Calculator will treat every number as an exact number. As a scientist, as a chemist, you have to know how to apply the significant figure rule so the number will make sense. So, significant figure will come from the device. Okay, let me ask you one question. So I have 3 devices here. One beaker, one graduated cylinder, one burette. Which one is the most precise and why? Now, how do I tell? So I have to look at the smallest division. That is going to give the significant figure. Smallest division. If I look at the first one, so again, the rule of thumb is 1/10 of the smallest division. So the first one, smallest division, is 10. So when you use a beaker to do a measurement, the significant figures are going to be 2 if the number is 2 digit, less than 100. Okay. When I use a graduated cylinder, the smallest division is 1. So the significant figure is going to give you 3 digits. Okay. If I use a burette, and that is a very important question, when you read burette, you read top down, but you are not going to use burette tomorrow, but you will be using burette for the titration, which is going to be the experiment number 4. So we'll go over that. Smallest division here is 0.1. That means it is going to give you 4 significant figure. So the higher the significant figure number means that device is more precise. So that brings the question, precision versus accuracy. Do you know the difference between these two? That is going to be your goal tomorrow. Which device is most precise and which device is most accurate? That you're going to do. Let me see if I have here. Tomorrow. So that is going to be your guiding question. Which glassware is the most accurate and most precise? So you need to collect some data, which you are going to do tomorrow. So what data are you going to collect? Okay. You're going to collect the mass and the volume. How are you going to collect? For the mass, you're going to use a balance. So you need to watch how to use the balance. I showed you. It's very easy. For the volume, you're going to use 3 devices. Very, very important. How do you reduce error? Every measurement will have some degree of error, uncertainty. Now, in day-to-day life, these have different meaning. In day-to-day life, error means mistake. In chemistry lab, you don't want to write the mistake. What mistake you have done. That is the measurer's problem. But every device will have some degree of error. That is called uncertainty. That you cannot avoid. Doesn't matter how good you are. What is your skill level? Doesn't matter. It will have some error depending on the device. That is the error we are talking about. And how do you know the error? So that is called range. So you're going to measure the range. So what is range? Everything is in your lab manual. Range equals the highest value minus lowest value. The difference between the measured value is the range. Okay. So there are 2 things. How do you reduce the error. How do you collect the data? Again, tomorrow I'm going to take few minutes in the lab. And how do you tell which one is most accurate and precise? So we're going to calculate the density. So you must know what is density. Density equals mass over volume. Okay. So the mass, what is the unit for the mass? Grams. What is the unit for the volume? Again, depending on the substance. Because you will be measuring water, the volume of the water and the mass of the water, so it is going to be in milliliter, the volume. If you take solid, that is going to be in cubic centimeter. If you take gas, that is going to be in liter, okay? Depending on the state of the matter. So whenever we call about density of matter, grams over milliliter, or grams over cubic centimeter, or kilograms over liter, that depends on the state of the matter, the type of the matter. Okay? So we're going to calculate the range and uncertainty. Okay? So the range is going to give you the precision, and uncertainty is going to give you the accuracy. Okay. Now, how do you enter these values? One thing I haven't yet mentioned, that is the pipette. So I'm going to show you that one too. How do you do the pipette? So if I go to, let me show you here. Okay, I think. Okay. So as you do the measurement in the lab, you're going to fill this one, and then also this is a PDF file fillable, so you can enter, but I suggest first you write in your notebook. So this page number 9, you write the date. Let me see. Here, your name. Now, because again, due to COVID, there is no group work here. So only your name. Section number 003. You write your name and you repeat the measurements. So, for example, first time, I take the beaker and know the mass of the beaker. Then I added some water. Again, it has to be more than 10. And tomorrow I'm going to ask you a question. Why more than 10? Why not less than 10? Okay, think about it.
Excuse me, Mr. Dutta.
Yes.
I have a class at 6, so I got.
Oh, okay, no problem. We are almost done. I'm going to, do you have any question? How do you enter the data? That's what I'm going to show you.
Okay.
And yeah, it will take another 5 minutes. So we have time, okay? We'll be done before that, okay? So first you're going to take the mass of the empty beaker. Again, for the mass, and you're going to follow the decimal place, since you're going to see on the balance. And every time you're going to have 3 decimal places. Okay. That means you can have 5 significant figure here. For the volume, depending on the device. So first you're going to use beaker. So the beaker won't have any decimal place. You can take 11, 12, 13, 14 because these are just estimate. Actually, beaker is not a measuring device, and I will explain later. You don't want to write the same number every time. Okay? Then with the water, you are going to take the measurement, the mass measurement again. When you subtract this minus this, is going to give you the mass of the water. And the density equals mass of the water divided by the volume of the water. Okay. I'll be happy to take a look, but again, we are not collecting any paper. So I'll use the whiteboard in the classroom to show you the calculations if you have any questions related to significant figure rule. So unless I write this one correctly, I won't be able to answer the final question, the guiding question. Which one is the most precise? Which one is the most accurate? That will come from the significant figure. So that brings the question, what are the rules for the significant figures? What are the rules for addition, subtraction, multiplications, and division? Okay, you need to read that one. Very simple. When you divide these two numbers, volume, mass over volume, so then you use the lowest significant figure as in the measurement. When you subtract, then you take the lowest decimal place. So for example, you subtract this minus this. So when you do the addition, subtraction, you go by the decimal places. When you do division or multiplication, you go by the significant figure. That is the hardest part if you are doing first time. And I will explain. When you know why you are doing that, then you will never forget. But first you have to know the rules. When you do addition, subtraction, you go by the decimal places. You write the lowest number of decimal places as in the measurement. When you do the division or multiplication, you take the lowest number of significant figure as in the measurement. So this is how we're going to fill. Now if I go to the next one, so this is for the graduated cylinder. Exactly the same way, you are going to use 50 milliliter beaker to hold the water. This is not a measuring device. The measuring device is graduated cylinder. In other words, I take the water into the graduated cylinder. Then I have to transfer it into the beaker to know the mass of the water. So first I have to again check the mass of the beaker. You need to double check. You don't want to write the same number again and again. And then I'll take the water and you are going to get this value from the graduated cylinder. You're going to measure the mass of the water plus the beaker. Then when you do the subtraction, you get the mass of the water. Then you can calculate the density, which is mass of the water divided by volume of the water. The same thing with the pipette. So the pipette you need to practice. That is going to take probably 10-15 minutes to practice. How do you pipette? Only thing you have to know, pipettes will have 2 decimal places. This is how it has been calibrated. It has only 1 marking. So then you know the density of the water using 3 devices. Here you're going to get the density of water using graduated cylinder. So average density, how do you get the average density? You take 4 values here, divide by 4. You need to show the calculations. Absolute error, how do you get? That will come from the theoretical error minus the average density. So how do you get the theoretical density of the water? That is actually in your lab manual. If you look at the page number 7, you have a density chart based on the temperature, and that's why you need to record the temperature of the water. and I'm going to show you tomorrow how do you get the theoretical value. The same thing here. If you have used the pipette, which is going to be 10.00. So in other words, if I use pipette, I'm going to show you tomorrow how do you pipette out. It is going to be 10.00, 10.00, 10.00, 10.00. You cannot take any other measured value using pipette. But these values are going to be all different. Could be 11.5, 10.5, 11.9, 12 point something. These have to be different. Okay. If I try to get the same value, then if you are going to take analytical chemistry, you will learn there is one terminology is called bias. You don't want to create a bias in the system. Okay? So you complete all this and then you enter into the fillable worksheet on Canvas. You can do during the lab right way. Then there is another worksheet that is kind of a little bit formal report you're going to write. Here also you can write, again this is going to be draft. Based on your data, which piece of glassware is the most accurate? Which piece is the most precise? Which piece is the least accurate? And which piece is least precise? Again, you summarize all the data here. Based on the values here, you're going to make a conclusion. Okay? If you need help, I'll be happy to explain during the lab when you are done. But after the lab, you're going to write a formal report, which I'm going to show you. Let me show you here. That is going to be, so this is the fillable you can do during the lab or after the lab. But this is going to be the final one. So if I do this one, you see you download this one and then you're going to upload. This is the report. Okay. So let me see here if I can download and show you. So this is the one. You're going to write guiding question. What is the guiding question? Which glassware is most accurate and precise? Now you can have more than one answer. You will have more than one answer. So one of them is going to be most precise. Another is going to be most accurate. You're going to write your claim. And the claim will be based on your data, whatever. It has to be consistent. Okay? You can guess that pipette is going to be most precise and accurate. But it has to be reflected on the table. The data has to be consistent. You will not be graded based on accuracy. Whether, for example, I know the pipette is going to be the best. But you may not get that. That doesn't mean you're going to lose point. Here the goal is to how do you interpret the data. You collected the data, you got the average density, you got the absolute error, you got the range. And how do you interpret the data to make a claim? Okay, that is going to be here. You're going to justify. You're going to write few sentences. And you're going to show here the sample calculations. Okay. So this is how you're going to complete the lab tomorrow. Now, since this is the first time, I thought it is very important that you know what you'll be doing. So you are fully prepared and you are not going to spend 3 hours with the mask on. I know it is not comfortable. Okay, I have to do the same thing. I will have face shield, mask, everything I will have. Because safety should be the first priority. Okay. We have to learn. We have to do whatever is necessary. But the safety should be the first. So I hope we don't have to spend 3 hours. If necessary, we'll take a break. Okay. Do you have any questions?
11:59 a.m., which is like during the class period. So once we do it in the class, we just go ahead and turn it in before that deadline.
Oh, I can change that one. So that is in the estimated time. But I expect you are going to finish by 2 o'clock. That I had to put some time to make you aware.
Okay.
But I can move that time, okay? So don't worry about that. Because if I put 11:59, so you may not understand when you have to do it. Because you know that during the lab you will be doing all these things. You may not enter. So after the lab, if you remind me, I'm going to change the time. Okay? And we have to keep doing this way, probably. Okay? So don't worry about that. Okay? Yeah. So only thing I didn't get a chance to explain the significant figure rules. But I said what are the rules. For addition, subtraction, one rule. For multiplication, division, another rule. I know some of you have to leave. If you want, I can take another 5 minutes to explain.
Mr. Duda, I got a question.
Okay?
So the pre-lab is not due until after the class?
Okay. So, I know the terminologies are very, very confusing. Okay? So, basically, the pre-lab, there are two different types of pre-lab, kinds of. One pre-lab is before you come to the lab, you do some work, okay, online. Then every experiment will have two labs, except the first one. You'll be collecting some data, that is also called pre-lab. During the lab, you will do the pre-lab work, okay? So I understand where the confusion comes from, because every lab, every investigation will require 2 weeks. First week is the pre-lab. The second week, actually, the actual lab investigation. But because of the COVID, we are not doing for every lab. So for the tomorrow's lab, you will be doing only pre-lab. So there are two pre-lab. You're doing, before coming to the lab tomorrow, you're doing pre-lab online. And during the lab, also you do the pre-lab. Okay?
Okay, so the one that's titled pre-lab 1 worksheet fillable, that's the one I need to have done by tomorrow, correct?
Yes, that you should do during the lab. But I'm going to allow you to give more time, so you will have time to complete by tomorrow night.
Okay, so I do not need to bring a pre-lab tomorrow, so I just do that tomorrow in class.
You will do, yes. But what do you have to do? Complete. Okay, so since you mentioned, let me explain this one. Go here. So you see the first module 0, okay? So these are also called pre-lab work. These are online pre-lab, okay? All the things you have to do tonight. These are due tonight, all the works. And this is also pre-lab. Investigation 1 pre-lab. You will be doing during the lab. But some of the things you have to do tonight. Before you come to the lab, you need to be prepared. So, for example, you need to watch the PowerPoint presentation. You need to watch the video, how do you pipe it. You need to watch the video, how do you use the digital balance. Again, the confusion comes because we are simplifying the lab. So we need to cut some of the portion of the lab. So we are doing only the pre-lab. You will not be doing actual lab for the investigation 1. Okay? But for investigation 2, you are going to do 2 weeks. First one is the pre-lab. Second one is the actual investigation. And then you have to write a formal report. For tomorrow's lab, you will not be writing any formal report. Okay?
Okay.
Does this clear to you?
Yes, I just watch the videos and do the syllabus stuff by tomorrow.
Right. And when you come to the lab, then you do these 2 work.
Yes, sir.
These 2 we are going to do. You can do during the lab.
Thank you so much.
Yeah, that's all. But before that, you have to, all these things you need to complete. Otherwise, you will not be allowed to come to the lab.
Yes, sir.
Okay? Is there any other questions? Okay, if not, I'm going to stop here. Or do you want me to take already 1 hour almost? I'll be happy to explain significant figure rules if you want. If some of you are
Is
not.
there a way that you can do the significant figure thing like in class in person?
Yeah, I'll check, but I'll take some time after you collect the data. We'll have some
Yeah,
time.
afterwards.
Yes, I'll do it anyway. Yes, but I just wanted to make sure that you are aware of what are the expectations here. Okay, I understand that you haven't yet probably learned in 1150, but that's why I'll spend some time. But I want to minimize, because you need to be present there with the mask and the gloves, everything on. So we have to, if it necessary, we'll take a break, and then maybe we'll go back again to explain how we're going to write the final report. Okay? Yeah, I'll explain again tomorrow.
Okay.
Okay? So if there are no more questions, so that's all for today, and I'll see you tomorrow. Thank you.
Thank you.